Hey, hello everybody. Welcome guys back. So we are in 2025 and we'll continue with our series of simulation of microcontrollers using Wokwi. So yeah, since you all know in 2025 everything now has a connection with AI. So we need also to include or get our hand busy with embedding some AI models into our simulations. So, sorry guys, I got some noise. Okay, so in this year, we'll be exclusively using VS Code extension because it's much more complete. And I'll start with the web-based one just for an introduction, for a brief introduction on how to use Copilot to generate diagrams and code, and also optimize code. And we just have to run and let the AI models to do the heavy work for us. Okay, so without further delay guys, let's get started with the beginner level. All right guys, so yeah, 2025 AI. So yeah, for this short introduction, I'll be using okay, I'm a French speaker. Okay, if you see my browser, everything is in French. I'm sorry. So all of my news are in French. I'm sorry for that. So yeah, get Microsoft Edge, and then if you're in China, please get your VPN because you will not have access directly to the international Copilot version. Okay, so go on to your browser and then write ESP32 new project directly. It will start a new template. This is a starter template for the Arduino framework. Okay, you can change the framework, for example, to the IDF or the MicroPython framework. Okay, so all of that depends on you. But for this first beginner starting one, I'll be using the Arduino framework and Copilot web-based one. And as I said, this one is limited, so that's why we will not be using it in most of our simulations because it doesn't have a direct access to our files, and then it cannot edit them directly, which is really bad. But there are some models that can do it in the web-based one, like Operator from OpenAI, but it's paid, and we don't want to use it. Or maybe some new models from Google Flash, so they can do it, and I don't want to use them. So that's why I recommend people to use the extension one, which is in VS Code, because in here Copilot has access to multiple models, and all of that model you can preview them or use them for free, okay, in VS Code. So yeah, without further delay, let's just ask this Copilot. So you just click on it and then it will pop up here, and then you can write whatever you want and then tell him to make a diagram, add a potentiometer, add a screen, make this, and then it will add it for you. But it's really buggy with the web-based one, as I said. But in VS Code, it's awesome and incredible. So let me first ask him if he can see my screen. Can you see the web page that I opened? So if he can see, so that means at least he can suggest code and diagram for us. And also, as I said, since this open Copilot doesn't have direct access to our files, then we can only copy paste, which is really bad, and I don't like it. Yeah, he said yes, he can see it. So one thing that you can do is just tell him to add a relay or add an LED. For this first one, I'll first add first LED. So an LED is an electrode, a light emitting diode, which has two electrodes. It has an anode, which is the positive side of it, and it has a cathode. So for us to protect this LED, because they have a breakdown voltage, we add a resistor. And in this case, we'll be using a 1 kilo ohm resistor here. So with this 1 kilo ohm resistor, we should connect it to the positive side of this, which is the anode. Anode it's positive, okay, for electrode, and if it is ions, it's cation, which is the positive. So this should also be connected to one of the GPIO that we want, okay, to make it as an output and in control. I'll connect it maybe to GPIO number 4, and this cathode means negative in electrode, and in ion, anion means, or anion means negative, okay, and cation means positive, which is different. So yeah, right now we have one single diagram. So let's just tell this Copilot to write a blink file, okay, write a code to blink the LED connected to GPIO number 4 for every, let's say, how many? Every 250 millisecond, okay, which is quarter second. All right, so it has generated. We copy that and then paste it. So you also need to understand, okay, so this is the setup, okay, the setup code. It's just enable this GPIO and then make it an output, and then in the loop, it set it high and low in every 250 millisecond or quarter second. Simple, right? You run it, it will build it, and then it will run it, and if everything's okay, it will start blinking every 250 millisecond. What the hell is happening? Taking too much time. All right, so now you can see it's working, right? So I don't like it because I have to be copying and pasting, copying and pasting. So let's tell him when the LED is on, print on, and when off, print off, right? So it will begin here, start a serial communication, and then set the baud rate of our serial communication to 115200, and then print on a new line on when it's on. All right, so let's copy that and then paste. I don't like this because it's really slow. You have to write and then also copy paste. So that's why we will not be using this in 2025. We will have to do most of our work in VS Code, and also the web-based one. Honestly, I don't know if it's my internet or is the browser. It's slow in building and then compiling. So let me do it again. All right, so since he says he has access to our web page, let's open the diagram. I'll copy this, and then I'll tell him to add a second LED. Holy cow, this is taking too much time. Let me do it. Based on the below diagram, so right now you can see when the LED is on, it prints on, and when the LED is off, it prints off. All right, in the serial monitor that you can see here. So that is great. So this is what we generated here, or he generated here, or it generated here. So now we want to modify this diagram. So I'm telling him that based on the current diagram that we have, add a second LED and resistor connected to GPIO5. So I was saying this is really buggy because it doesn't have direct access to our files. So whatever we just do is we give him backup information, and then he generates some codes, and then we test it, which is really not great and efficient. So let's first see what he's generating. Okay, so in here you have the version, which is 1, the author, which is Nicholas, and then the editor, which is Wokwi, which is correct. Now, in terms of part, we have the ESP32, which is this board. We have LED number 1, which is this red, and you can see the color here, which says red. And this is the position, okay? And then we have a second component, or a third one, which is this resistor called R1, and its position. And then it's been rotated 90 degree, as you can see, because originally it was like that. And then its value, which is 1 kilo ohm, okay? And then we have a third one that he added, which is LED number 2. And then his color is green, which is different from this red. And also he added a second resistor, which is resistor R2, and which is also a 1 kilo ohm. Now the problem might be in the connection. Let's see if the connection is correct, especially on the LED number 2. The cathode is connected to the GPIO, to the green, to the GND number 2, which is correct. This is purely correct. That is correct. He's right on that. And let's see R1 or R2. The one side of R1 is connected to LED 2, which is correct, and the other side is connected to GPIO number, oh no. So you see here, yeah, GPIO number 5, yeah, good. So, and he uses the blue wire, which is awesome. So I think that this will be okay. So, and also he generated a code below here, and this code is for both, okay? So let's first get the diagram. So you can see the first one in green and the second one in blue, and he connected the second GPIO, the second set of LED and resistor to GPIO number 5, and the first one that I drew myself is here, and he generated the code. So let's paste the code here, and then run it. So right now what he is doing is like he is blinking. Oh, what is 205? It should be 250. Anyway, so it's blinking all of them at the same time at a frequency of 250 millisecond or 205 millisecond. And whenever it's on, it prints on, and whenever it's off, it prints off. So let's say that we edit the code, oh, not that one, to blink the first LED every, let's say, 500 ms, and the second LED every 250 ms, okay, every 250 millisecond. So we can see what he has generated here. So first LED on, delay 500 millisecond, turn it off, print, and then turn on the second one, and then print that is on, and then turn it off, and then print that is off, based on the timing. This is half a second here, and then quarter a second there on the second LED. So that is correct. So let's again restart. Thirteen. So let's cancel it and then restart it. All right. So now when the first one is on, we'll have first LED on, and when it's off, we see also first LED off, and then the second one will turn, we see second LED on and second LED off. So yeah, that is it. You can also, because this is really not good for, I would say, multitasking, you can also change all of this to be in FreeRTOS. Okay, so rewrite the entire code to use FreeRTOS with two different tasks. So one single task can do both of, like, blinking both of those LEDs, but I just want you to know in terms of multitasking, so that you can have two tasks. So you have one task which is blink first LED one, and then a second task which is blink second LED. Okay, and yeah, let me copy and then come here and then explain. So this is the setup we all know. We have both GPIO set as output, and then we begin the serial monitor with the baud rate of 115200, and we have to call these two tasks because these two tasks, they'll call the handler of these two tasks here. So this is the task assignment, and this is the task itself. So what we want to do in the task. So if you check, let me try to open it a little bit. So if you check, we have this first task, okay, and this is the name of the task. It's called blink first LED, and this is the function, okay, of that task. If you click on this, you'll see this is the function that will be executed, and this is the stack size that we are allocating, or let's say the size or the part of the memory that we are assigning to this task. Okay, it's called the stack size, and this will be the handler. So here he didn't add the task handler, so that's why it's no. And this is the priority. Okay, and normally if we are uh, sectioning the core, because it's dual core, if we are sectioning the core, we also have to specify the core. Okay, if it is core 1 or core 0, we have to specify. So this priority, the lower it is, the higher priority the task is. Okay, so the same thing for this. So you can change this, and this will be the minimum. So I'll make this one 3000. Okay, and you can also, if you make this one 0, so that means this is the highest, okay, priority. When, for example, the memory is too much busy, it will give priority to this first task because the priority level is low. If I make it 2, then this task becomes the most prioritized one. Okay, and most of the times also when you give more priority to this, you have to give him, makes sense to give him a bigger stack size, okay, in the memory side. All right, so let me just use 2000, and then let's run it, and then you see. So okay, if you want to know also the task size, so inside here we have two things. This very first one here, okay, all of this represent your setup. Okay, it's also this function is whatever is here. So you could have just taken this one and then put it here, it will work the same thing. And now this while true is just your loop function here. So whenever this task is called, it will do this one once and then get into this and then be here looping until this is false. And most of the times we do it to be true all the time. And this is the delay, okay, the delay of the task. So it will be looping into this function every half second, which is 500 millisecond. So, and this one, you know, serial print. Same thing for the second task. So we have this setup function or this setup side, which is this. From here up here, you can, for example, you could have just pin mode something, and then copy and then paste it here. It will be the same thing. And then this is the loop, which is just this function here. So whenever this function, okay, this task is called, then it will get into this loop. It will first do this setup once. If you have anything here, it will do it and then get inside this function, and then it will be looping here every quarter second. So yeah, as I said, we'll not be wasting too much time in the web-based one. We'll be much more focusing on the extension, the VS Code extension one, where the AI model has direct access to our files and it can edit it instead of we copying and pasting it. And also when it has direct access to our code, it has much more understanding of what we want and it can do it better. So guys, thank you very much for watching this. This was just a refresher. Let's get started with the real world project. Thanks for watching. Bye bye.